G of -2. So we plug in -2. And we get 4 minus 9 is -5. We plug in -2. H of -2. Seems to be a common thing. 2 is an easy number. So we plug in -2, we get 4 plus 6 minus 10 is 0. Okay, we plug in -2. We get -8 when we cube -2 minus 8 gives me a -16. All right, you try the second row. Now you're welcome to use your calculators, guys. Guys, I think I have lost all control over my thermostat. Right now it's on 55, and it's nice and toasty in here. It's almost hot in here. The heat kind of makes me weary, because the warmer it gets, the sleepier you guys tend to get. So I try to keep it coolish in here, because generally you stay awake. So I think I will open the door today and we'll see what happens.
When you leave the air cold and it's already cold outside, your air is going to be lower than your air is. That is what the air was.
Alright. F of 3, what'd you guys get? 5. G of 3. 0. H of 3. K of 3. Okay, so we know how to evaluate, and I'm going to snip these and I'm going to steal them for our next page. So let's snip. We'll copy these. That way we can see it when I move on. Oh, wrong button. Try again. Okay. So let's take a look at this. Now, these are interesting ideas. This says add the two functions. Well, we know how to add polynomials. Add like terms. This says subtract the two functions. We know how to do that. This says multiply the two functions. We know how to do that. So, or they could just put them side by side. And this says divide. We know how to add, subtract, multiply, and divide. So, if we had to add the two functions and then evaluate. Alright, so f is this. So if we added f plus g, let's see what f plus g is. So we did 2x minus 1, and then we added to that x squared minus 9. We get that f plus g is x squared plus 2x minus 10. Okay, and now if we plug in -2, we would get 4 minus 4 minus 10. 4 minus 4 is 0, minus 10 is -10. Alright, real quick. We just said f of 2 is this, and g of 2 is this. If I added this and this, do I get that? Oh, I do. You can, okay, let me go back over it. Okay, so, okay, that's fine. How about this? You watch, and then I can print the notes out for you. Okay? Alright, so, f of g was 2x minus 1. Excuse me, f of x. And g of x is x squared minus 9. So this says to add them. So we added the like terms, and we got this. And then, if we evaluate -2 for this sum, we plugged it in and got -10. But then we negative 2 is negative 5. If I added this negative 5 with g of negative 2, which is also negative 5, what is negative 5 plus negative 5? Negative 10. Okay, let's see if that holds true in all the operations. Does it work for subtraction? Does it work for multiplication? Does it work for division? Because you know, sometimes things work for addition, but they don't work for subtraction. Sometimes things will work for multiplication, but they don't work for division. So let's see, let's test it.
Why would you put the F when you're just plugging it in?
Because that's what the problem asked me to do, was to add them.
I know, but you had already done that. Why would you repeat it?
I was just showing you
Oh,
that,
okay.
that this work gives you that.
Oh, okay.
Okay, I won't repeat it this time. F minus g. So I'm going to write down F. And you're right. I do know the answer to the question I've already asked. Yes. Okay. So this time it's F minus h. So we're going to write down the h. Now, when we subtract, we change all the signs, right? Remember? We change all of them. All of the signs and the polynomial that follows the subtraction. Okay? So, this gives me negative x squared plus 5x minus 9. So, if I plug in negative 2, and I'm going to slide it up top here, the opposite of negative 2 squared, that should be plus 9. You guys are right. And then I do 5 times negative 2 plus 9. So this gives me negative 4 minus 10 is negative 14 plus 9 is negative 5. Now what would happen if I did f minus h down here? So f was negative 5 and h is 0. Are those two the same?
Correct.
Yes. Woo, I'm seeing a shortcut. Let's see if it works on everything. Alright. Now this multiplication is just ugly. Because h of x is a big old trinomial. So h of x is x squared minus 3x minus 10 times k is x cubed minus 8. Alright, so if I'm going to multiply this times this, and when we multiply like bases, we add the exponents. And then I'm going to multiply it times the next one, and then the last one. And then I'll distribute that negative 8 through. So that gives me negative 8x squared,
That's a large number.
positive 24x, and then positive 80. Okay, so ugly, but that's what it is. So if we evaluate this for negative 2, if we plug in negative 2, I get negative 32. If we plug in negative 2, I get 3 times 16. And if we plug in negative 2, negative 2 to the third is negative 8. And when we plug in negative 2, we get 4. And when we plug in negative 2, we get positive 24 times negative 2. Come on, Moby. You can do it. And then plus 80. Okay, so this is negative 32, and this is negative 48. And this is positive 80. Those cancel, don't they? Because that's negative 80 and plus 80. That's 0. And this is negative 32, and this is negative 48, and that's plus 80. And those cancel, so it's 0. What would happen if we took h of negative 2 times k of negative 2? We would get, is that equal to 0 times negative 16? Yeah, that is 0. Okay, so it has worked for addition. for subtraction. It worked for multiplication. The final test. Division. Division. Alright, so K is x cubed minus 8 over G. And G is x squared minus 9. Now we have to be careful. When we show division, if we're not just evaluating, if we're just showing division, we have to be very careful because the denominator of a fraction can never be 0. The denominator were ever equal to 0, it would be undefined. So if we were not evaluating, if we were just showing division, we would have to say, well guys, x cannot be positive or negative 3 because that would make the denominator equal to 0. But luckily here we're just evaluating. So let's plug in negative 2 and we get negative 8 minus 8 over 4 minus 9. So we get negative 16 over negative 5. Now, do you see if I did K, negative 16, over G, negative 5, I'd get the same thing. Yes. 16 fifths. Okay, so, you try evaluating with the 3's. You try evaluating with the 3's. Feel free to use the shortcut.
Easy shortcut.
Friday?
Say Birdsong, right?
I think it might be James.
It might be James. James
Yeah,
had
James
that
had
coffee.
it.
James in court right now.
Yeah, she's not something you said.
Yeah.
Especially when I'm recording.
What? Ashley, this one's for you.
Shut up. Shut up, Ashley.
Alright. 8 is negative 10. G is 0. Did you get negative 10?
Oh my God.
Oh, I thought we were doing you were talking about 1, 2, 3. Okay, my bad.
Oh, I just did the wrong thing.
Yeah.
G is 0. K is 19. Did you get negative 19?
Yep.
Good. I don't know what I just did. Alright, F is 5. F of 3 is 5. H of 3 is negative 10. So here we're multiplying. Did you get negative 50? Okay. K is 19. Plus 5. Did you get 24? Okay. G is 0. Divided by anything that's not 0 is 0. 0 divided by any non-zero number is 0. 0 divided by 0 is not defined. Okay, so now, what if the notation doesn't have a number right here? Then you have to do it the long way. Okay? So, in that case, if we do not have a number in which we're evaluating the function for, we just add them. So F and G. We've we've already done it. 2x minus 1 plus x squared minus 9 is x squared plus 2x minus 10. That is all we can write. That's it. That's as simple as it gets when they don't give us a value. That's what it looks like. This is the problem. That is our answer. Okay? To subtract them, same idea. You write h first. You subtract from that g. And when we subtract, we have to completely distribute the negative. And so, in this case, h minus g of x is equal to, the x squares are going to cancel. It leaves me negative 3x minus 1. Alright, f dot k, that means times. So we would write down the function f and multiply that times the function k and distribute. So we get x2 x to the 4th and then minus x cubed minus 16x plus 8. And I went in that particular order because I saw that would put my answer in the correct form. Now, the only trick is this. This is division when we haven't defined a value for x. And this is where we do have to state what x cannot equal. So k over g. K is x cubed minus 8. G is x squared minus 9. And we have to state what values of x that would make the denominator 0. Okay? So we could factor. This one factors nicely. What does x squared minus 9 factor to?
X plus 3.
Good. So what values could I plug in here that would make this one equal 0? Negative 3. And make this one be 0? Positive 3. We can't have 0 in a product because that would make the whole thing 0. So this is the answer to division, but we must state the restriction on our domain. X cannot be positive or negative 3 in this case. Okay? We're going to skip to number 3. Alright, so let's skip to 3. So let's do f, which is 2x minus 1, over h, which is x squared minus 3x minus 10. Now, division is easy. We just can't forget the restriction. What can x not be? So we factor this denominator, x minus 5x plus 2. What values of x would cause that denominator to equal 0? 5 and negative 2. So those are the restrictions on the domain of that function. Those are the values that that function cannot have because it's where it's undefined. These are the cool graphs, guys, that are the curves that'll have just a point missing. And you know how a lot of the functions we've been doing recently have had jump discontinuity? Some of these will have point discontinuity when you have a value like this.
Oh, slow down.
Okay. Last one we're going to do together, and then the back is yours, is number 2. And this one I'm going to come down here because we're going to need more room when we get to where we're going to do the denominator. So writing it as division is simple. Okay, but this is one of those difference of cubes. It's a subtraction. And it's wonderful because it helps us remember. What are the patterns for the signs when it's
Minus,
negative?
plus, plus.
Minus, plus, plus. What was being cubed to get x cubed? 1x, yes. What is being cubed to get 8? 2. So the x and the 2 go here. You square the first one. Product of the 2. Square the last one.
So how would you write that?
Okay. So the first part is easy. I see it. X cannot be 2.
That's it?
This is not so easy. It's a quadratic that doesn't factor. Negative b, plus or minus square root, plus or minus square root, b squared minus 4ac, b squared minus 4ac, all the way to it, all the way to it. Here we go. Negative b, plus or minus the square root of b squared minus 4 times 1 times 4, all over 2 times 1. The nice part about this, guys, is it's also helping us remember imaginary. Okay? So this ends up being 4 minus 16, which is negative 12. Negative 12 breaks down to negative 4 times 3. So it's negative 2 plus or minus 2I root 3 over 2.
Hopefully cancel out front.
But everything divides by 2, so we get negative 1 plus or minus I root 3. Weird. Okay. So the back is your homework. You have the rest of class though, which is a lot of time. Now, some of it, it's only 16, but each one of them is only asking you to do one thing instead of 4 things. Like number 1 is just asking you to multiply and evaluate. Number 2 is just asking you to add. Okay? So, last period did tell me the copies are a little light and it's hard to see some of the signs. So if you could darken your sums and your differences and your products and your quotients so that you can tell what is what. Those of you that are watching the video, I will also add this to the last 2 pages of the slides.